Okay, I'm going to go over the key information off the blueprint. You have a test Thursday. It is the last test of the 6 weeks. It is majority multiple choice with one griddable, one open-ended Thursday. So that would give you 4 tests. So we're dropping one of the lowest of 1, 2, and 4. The only test that does not get to be dropped is the district assessment. So it counts. It can only help you if you do better on it. All right. So this is the first test of a circle test. We're gonna have another test over circles when we start the 6 weeks. So the information that we're gonna assess you on and stuff we've already assessed you on, we're gonna keep spiraling it for the next test. So don't think you're never gonna see this again, because we're gonna keep building on. We're not done with the circle unit. All right. So I put up here that 20 questions, 7 matching, 12 multiple choice, 1 free response. Of your matching, please pay attention. Your vocabulary will be the matching. On your review, you have a figure. It's already been drawn for you. It has certain segments labeled, and you have to give the name of that part in the circle. No word bank. Word bank is your answer choices, basically, if you want to look at it that way. Yes, you will get that back today. Put that away. All right, now you have 2 questions finding the arc measure. We've done this before already. You will need to use prior knowledge, vertical angles, right angles, semicircle, any parts of the circle. So here's an example. I'm trying to give you examples of each type of problems or each concept you're going to be tested on. So and I think I've given this picture before, but if I know that this central angle is 47, then it's vertical, so angle Q. PR is also 47, and then you should use what you know about a circle to find that missing part, okay? Because the measure, anytime you see lowercase m, that means measure that's talking about degrees of arc QS. The measure of that curve corresponds with that central angle. So you need to know angle RPS to come up with the measure of the arc QS. Could you find that missing piece? Anyone find it? Well, we know that this cuts the circle in half, right? Yes. So we know that's half is 180. If you add these 2 together, QS is 120. Well, this is right here, a 78. Yes. Yeah. And then when you add the 2 pieces together, it's 70. Yeah. Sorry. So to get the arc, 125. I'd rather cut it in half than to go a bigger piece. So if I did do, you did what, QPS? You talking about this angle here? Yeah. Yeah, but you just gotta know that that's the vertical piece to that is over here. It's not really going to give me, okay. You can do it however you want. Okay, do it however you want. All right, then you're going to have 2 questions converting from degrees to radians and radians to degrees. All right, so what I put up here, this information, not on the formula chart, so you need to memorize. Know how to do both. You have 1 of each. If I ask it in radians, you should see a pi in your answer, basically. If I ask for degrees, there is no pi in your answer. All right, so those 2, I'll give you an example. Try the example. If you're stuck, then you need to let me know. I'll go over it. You have 1 question asking for the arc length. It will be similar to this circle that I have over here as an example. The formula that you need to memorize, I probably need to underline that this needs to be memorized. That S represents the arc length. That's just the symbol they use for arc length. Then R is your radius, and theta is the angle of the central angle of the part we're looking for in radians, meaning there's a pi in the answer. 38. Where's the 38? Where are you talking?
Are you supposed to multiply 19 to?
Okay, so 19 represents what?
The radius.
Okay, 19 represents the radius. All right, and then 2 pi divided by 3, or 2/3 pi, what does that represent? What does this represent?
Central.
Yes, so this is the theta. It's the central angle in terms of radians. So that's your theta. And where m is actually what part? That is really your s, your arc length. That's what we're trying to find. So s or m is going to be r times 2 pi over 3. You just multiply the two together.
38.
Mm-hmm.
So 38 over 3.
What was my radius? Oh, sorry, 19. Radius was 19. $38 pi over 3? Yes. Yeah.
It says pi answer.
Pi in your answer. All right, and then you're going to have a question dealing with Pythagorean theorem. Using Pythagorean theorem to find a missing segment. All right, so we might have didn't get all the way into this, but this line right here is what type of line? What part of the circle would that be? Tangent. All right, very good. All right, so this tangent is coming from the same, and this tangent over here, they're coming from, I'm just going to put not going to put an X because we're already looking for an X. Let's put A. They're coming from the same external point. Those tangents are perpendicular because you see the box to them. But because the tangent is coming from the same point, then the tangents are going to be the same, meaning they're going to be congruent. So both of them, yes, oops, are 9. Both of them are 9. So, yep, and we're done. X is 9 root 2. You will be using prior knowledge, that's what I'm saying. All right. Okay. It's right, isosceles? Okay, there we go. Yeah. Yeah. Huh? How do I know it's 45? Because the two legs are congruent. And it's a 90 degree. If the two legs are congruent, then the two angles have to be congruent.
Yeah, how do you know those? Well, because
The tangents, yeah. All right, on the next page, I would say probably the bulk or some of the most difficult, two of the most difficult questions is dealing with writing the equation of the circle, okay? All right, because you're going to have one where I'm giving you the graph, just like here. You have the graph. I don't tell you the coordinate of the center, but you can read it. And then you have to figure out the radius, so you might have to draw it. But you have to look off the graph and then give me the correct equation, okay? You basically follow the formula, x minus h parentheses squared plus y minus k parentheses squared equals the radius squared. I think most of you showed proficiency and mastery off of this, off the district assessment. I'm not worried about that type. But you have a type where you're given a center and a point, or given just 2 points. That's over here. That's why I put a star to number 3. That means that you are going to have to find the center using the midpoint formula, which that formula is on your formula chart, and then find the radius using the distance formula. That formula as well is on your formula chart, okay? And then once you have those two parts, then you can plug it back into the standard form. So, but of the hardest ones, it's going to be number 1, where you have to complete the square. I've given you an example of that, and there's plenty on your review. And if you did the notes, which some of you didn't looking at your spiral, where it says more equations with circles, there was a video of that. There were some more equations dealing with completing the square. So maybe go back on Emoto and look at that. But basically, the first thing you have to do is combine like terms. So we get all our x's together, x squared minus 4x, minus 6, or y squared minus 6y. Then complete the square. Take the number in front of the x, which is a negative 4 here, divide it by 2, then square the answer. So negative 2 squared is 4. That's why they added 4, and they added 4 to the other side, because you have to get variables on the left, constants, which we call numbers, on the right. So to do the same thing with the y, you take the coefficient of y, the number in front, divide it by 2, then square it. That's why we got 9. And then all you have to do at the very end is we have these grouped together. We're just going to factor that out. Here's the shortcut, and you might want to pay attention to this. Whatever number that we square, like the number that we added to it, is a perfect square. So we're just taking the square root of that number. And then you look at the sign. What's the sign between the x squared and the 4x? It's minus. So it's going to be minus in the parentheses. What's the square root of 4? So there's the 2. So it's x minus 2. Same thing here. For the y's, we group those together. What's the square root of 9? What's the sign between y squared and 6y? So it's going to be minus. So y minus 3. Where's the 6? What do you mean?
Oh, when you multiply it out.
Yeah, it becomes, yeah, when you actually FOIL it out, that's where the 6y comes from. And then here we just add them up. -8 plus 4 plus 9 left me with 5. That 5 is the radius squared. So to get the radius, you have to take the square root. All right. And then I gave you an example when you're given 2 points. Could you write the equation of that? So you might want to try that one. And the last section is 2 to 3 questions, 3 questions, dealing with tangent theorem and chord theorem, okay? Add this to your notes. We looked at this in our packet. The tangent is always perpendicular to the radius. Okay? You're going to have to show that on a figure. It will not be marked for you. You're supposed to know it and then apply it. So, for example, right here, FE, I think that's an E, is the tangent because it intersects only at one point. And if I was to draw the radius from J to E, it would be perpendicular. Meaning, by knowing that, you could, if you had to, draw another segment from the external point to the center, and now you have a right triangle and use Pythagorean theorem. You're going to use Pythagorean theorem to find missing parts. So, over here, I'm going to look at example 3 on this side. They drew the tangent. They have already drawn the radius. You need to add that it's perpendicular, because the tangent is always perpendicular to the radius. You have the angle 27. They want you to find the other acute angle in the right triangle. This should be mentally, we're done. No Sokotoa. You're making it wait. Not even. I don't need to add. I don't need to add 90. No special. That's it. 90 minus 27, and we are done. In a right triangle, the 2 acute angles are always complementary. So it's always going to be a sum of 90. So I don't need to use this 90 because these 2 are going to always be 90.
Oh, yeah.
So just do 90 minus the other acute angle, and that gives you the remainder. Work smart, not overwork. All right. The other theorem. Yeah, I'm asking for TCB. That angle. Yeah, this is here, this is there. That's that. That is that. Yeah, you getting because you need to know how to get that angle too. Yeah. All right. Now the last one is if you have 2 tangents. Let's say I have a tangent coming from this point to that circle.
What is the x pointing to exactly?
Huh?
What is the x for exactly? Like the whole side?
It's a little segment.
It's just that little segment.
Oh, I got you.
I have a tangent coming from that same point. They kind of make a little hat or a cone head. I know that's not a good accurate drawing, but whenever that happens, the tangents are always going to be congruent.
Yes.
All right, so I need you to understand that on this very bottom side right here, this 18 is a tangent coming from this external point. This is also a tangent. So that little piece, yes, would equal 18. If one is 18, then one across of it, the tangent across it, would be 18. So now if I know the whole side is 16, 26. If this whole side is 26, and the missing part, yes, this little part right here would be 8, right?
Yes.
So 18 and 8 would give you 26. And then these two are tangents, so x is 8, and we're done.
That is pretty cool. I'm ready for
All right.
Yeah, good fight.
And then last one, this is also cone head. So those two tangents are congruent, so you would just have to say 2 times 3 plus 6x is equal to 14x minus 8. And then solve for x. All right, so that's the breakdown of your test. You have the review. You just picked it up. We're doing evens right now in class. So I'm going to stamp and check off evens today and the first thing tomorrow if you don't have them checked off today. I'm going to give you back your information.